So we're going to look at testing a couple of bitwise functions. And so what we're going to want to do is write two Python functions called high common bits and low common bits. Given two inputs, A and B, which are integers that are the same size, let's say 32 or 64-bit integers, return an integer with the same bit width with the high order bits that the two inputs have in common are included in the return value. The first bit where the two inputs differ at a bit position starting from the high end is set, and all remaining bits are cleared. Okay, so that's probably completely unclear just as a list of requirements. So let me do an example. So if A is 10101 and B is 10011, then the output is going to be the high order bits that they have in common. So the 1 is in common, it's set in both inputs, so we return that. The 0 is in common, so we copy that to the output. This bit is different, the third bit is different, so we want to set that bit and clear all remaining bits. So hopefully that's clear. So we copy bits that are in common until we find a difference, we set that bit, and everything else is clear. Now we also want to implement a function called low common bits that does the same thing except starting from the bottom end. So if we take the same example and we do the low common bits, we'd start at the bottom and see that 1 is common, so we copy it between the two. The next bit, the second bit from the bottom, is different, so we set that bit and we clear all the rest. And so what you might be saying to yourself at this point is, these functions look really silly, that this looks like a contrived example that a professor would come up with just to mess with students, but that's not actually the case. These functions come from an optimized trie implementation. What a trie is a kind of a balanced ordered tree, not incredibly unlike the display tree that we already looked at, and some of its friends. But tries rely on bitwise operations to find the descendants of nodes in order to get really high performance and really low memory footprints.